part 99 of C# tutorial. In this video, we'll discuss what lambda expressions are with an example. This is continuation to part 98, so please watch part 98 before proceeding. In this video, we'll be working with the same example that we worked with in the previous session. So, what are lambda expressions? Anonymous methods and lambda expressions are very similar. Anonymous methods were introduced in C#2 and lambda expressions in C#3. In most cases, lambda expressions supersede anonymous methods. If you recollect from the previous session, we have used anonymous method, as you can see here, to find an employee with ID equals 102 from the list of employees that we have got. And notice the usage of anonymous method here. We explicitly use the delegate keyword, and then we specify the type of the input parameter. Here the type of the input parameter is employee. The same example is rewritten here using a lambda expression. And notice how simple is this lambda expression. First of all, this operator right here is called as Lambda Operator, and it reads as goes to. Here Emp goes to Emp.ID double equals 102. So that's the lambda operator. And what is this Emp on the left hand side? This is nothing but the input parameter. Okay, now first of all, notice that we are not explicitly using the delegate keyword within the lambda expression, and number two, we are not specifying the type of the input parameter. Okay, so how is the lambda expression going to know the type of this? It is going to infer that automatically. Look at this find method. It's being invoked on this listEmployees object. What is this listEmployees object? It is of type listEmployee. So Emp here is going to be automatically inferred to employee type. Let's actually look at this in action. Let's flip to Visual Studio. So this is an anonymous method. Now let's replace this with a lambda expression. So find Emp goes to, and look at this, when I hover my mouse over, look at that, it says Emp is of type employee. So the type is being automatically inferred, and we are not using the delegate keyword explicitly here. And we can say Emp.ID double equals 102. Let's go ahead and run this and see if we get the same output. Okay, look at that, we get the same output. Here we're using a lambda expression. Notice how simple it is to use. They're more convenient than anonymous method. Now here the name Emp, it's just a name, any meaningful name. You can give it X, for example, if you want to. Okay, so this is the input parameter name, and this is the expression, and this equals greater than is nothing but the lambda operator. Alright, so now here we haven't specified explicitly the type of the input parameter. Now for some reasons, if you want to be explicit and if you prefer specifying the type of the input parameter, you can do so as well. Look at this here, we are specifying the type of the input parameter explicitly, but that's not required, which means we can rewrite this one like this. So include a bracket, and that X is of type employee. Okay, now let's run this and see if it works the same way. Look at this, it works the same way. So you can, or you may omit the type of the input parameter. That's going to be automatically inferred. Alright, so this operator is called as lambda operator, and we read that as goes to. Notice that with the lambda expression we don't have to use the delegate keyword explicitly, and we also don't have to specify the input parameter type explicitly. The parameter type is automatically inferred. Lambda expressions are more convenient to use than anonymous methods. We have seen that in action just now. Lambda expressions are particularly helpful for writing link query expressions. So let's flip to this demo that we have. Let's bring in the link namespace, so using system.link. Now let's say, for example, from this list I want to find out all the employees whose name starts with letter M. Now in that case we can use the count function. So let's go ahead and use the count function. So int count, so that function is going to return the number of employees, which is of type integer. So listEmployees.Count. And if you look at this one again, there are two overloads. The other overload is expecting a predicate to be passed. Now we'll discuss what this func is all about in a later video session, but basically we need to specify our predicate here. Okay, so again we can use lambda expressions. So what do we want to do? We want to find out all the employees, the count of all the employees whose name starts with letter M. So how are we going to do that? So again, you can give the input parameter any name you want. So I can give X, so X such that, now notice that here we have used the name as X, the input parameter. Again we are using X here. Now what is the scope of this parameter X within right there? You cannot use outside of that scope. Okay, so that's why we can reuse it here if we want to. Okay, so X goes to X dot name of the employee dot starts with, and we want to find all the employees whose name starts with letter M. And look at this count method is actually returning an integer. We are storing that in this variable, and let's go ahead and print that out. So console.writeLine, let's just say count equals whatever is present in our variable. Right, so we should get 2 as the output. So count equals 2. Right. So in most of the cases, lambda expressions supersedes anonymous methods. To my knowledge, the only time I prefer to use anonymous methods over lambda expressions is when we have to omit the parameter list when it's not used within the body. So anonymous methods allow the parameter list to be omitted entirely when it's not used within the body, whereas that's not the case with lambda expressions. Let's understand this statement with an example. Now, if you recollect from the previous session, we worked with this Windows Forms application as well. And what did we do within the form load event? We have created this button control dynamically. We have assigned the text property, and to the click event, we have hooked up an event handler using an anonymous method here. Now if you look at this click event, so let's navigate to the event. So here we have the click event, and if you look at this event handler and go to the definition on that, that's again a delegate, and it expects two parameters. One is of type object, the other is of type event args, and it's not going to return anything. Okay, so now the delegate that we are going to create here, we need to pass basically two parameters, that is object and event args. Now with the anonymous methods, we can write this piece of code right here. Let's actually copy this and paste them right there, and let's change the names. Let's call this event sender, and let's call this event args. Okay, now let's go ahead and run this. It's going to work. Okay, let's click that button, clicked. Okay, so now this is matching with what we have right here. Okay, so it compiles, it works fine. So here we are using anonymous method. Now I can get rid of these parameters altogether, because within the body right here we are not using those parameters. Okay, so when I get rid of those parameters, look at this. First of all, when we build this, in the build status bar, build succeeded. When we run this, it's going to work as well without any problem. Okay, button clicked. Now this anonymous method can be replaced with a lambda expression. Okay, so that's the anonymous method, and this is the lambda expression. Look at that, we are using that lambda operator, and here we are specifying the parameters. Okay, now within the body, again, we are not using parameters. These two parameters are not being used within the body. But what's going to happen if we omit those parameters? We will get a compilation error. Let's actually check that in action. So now we have got two parameters here to be passed. Now how will we know what are those parameter types? Look at this. The moment we open that, this click is an event, and the delegate that is associated with that is this one, event handler. It's expecting these are the two parameters. So let's actually copy them, and let's go to the form. So again, here, do we need to specify the names of the types of the parameters? Not required. the lambda expression can automatically, you know, infer them. Okay, but if you want to be explicit, you can specify them like so. So those are the two input parameters. That's the lambda operator, and here we have our expression. Okay, so let's go ahead and run this first of all. So it works. Let's click that. So the application is working as expected. Now we don't have to explicitly specify the type, so let's get rid of them and see if it still works. So let's run this, click the button, so it still works. Now let's actually get rid of these parameters altogether. Before we do that, look at this. When I hover the mouse over, look at this. This is of type object event sender, and event args is of type event args. Okay, so the input parameter types are automatically inferred. Now what do you think is going to happen if I get rid of these two? Save it, and let's build the application. Look at this. Delegate system event handler does not take 0 arguments. So irrespective of whether we are using those parameters or not within the body, we still have to specify them when we use lambda. But whereas that's not the case with anonymous methods. Anonymous methods allow the parameter list to be omitted entirely when it's not used within the body. Alright, that's it for today. Thank you for listening. Have a great day.